Okay, so the unit that I am starting is network design, and today the Lawrence and Abid is available. So I will just go through the learning outcome one, that is understand networking fundamentals. So obviously you will be able to evaluate the rules of network protocols, evaluate the hardware and software, assess common methods of managing mobile devices on wireless networks, analyze tools and available to manage a network. The indicative contents are network protocols, network hardware, software, wireless networks, network management, and internals will be like role of network protocol, protocol types, network protocol examples, hardware, software, wireless networks, network management, and these things. So, have you ever studied this unit before?
Yeah, I have.
Okay, that's good. So, networking is a very good unit that is mandatory for computer professionals, and really depends that at what extent do you learn and study that what do you understand, and it can lead to very specified the qualification, like you must have heard about the CCNA, Cisco, and the network of and the administrators and their administrations, and it stands basically the a backbone of the today's networking world. When we talk about the networking, it means we talk about, let's say, about the LAN, WAN, and internet, obviously. So if you have gone through these terminologies, then it's good. Otherwise, we will be going through these terminologies one by one. Yeah.
Yeah, sure.
Okay. So now let's say we start with simple definitions. Network design, learning outcome one, understand networking fundamentals. So let's see what are the network protocols, the function of protocols. For example, the protocols are rules and procedures for communicating. So when you say protocol means rule. The term protocol is used in a variety of contexts. For example, diplomats from one country adhere to rules of protocol designed to help them interact smoothly with diplomats from other countries. Rules of protocol apply in the same way in the computer environment. When several computers are networked, the rules and technical procedures governing their communication and interaction are called protocols. Keep 3 points in mind when you think about protocols in network environment. Number one, that for example, there are many protocols can be there. While each protocol facilitates basic communication, each has different purposes and accomplishes different tasks. Each protocol has its own advantage and restrictions. So it's not very simple. For example, let us take it from the very scratch. When you send a message, for example, if we are sending or if are communicating in if I'm communicating with you through computer, and it's not that much simple that your laptop is transforming my voice to you, but it is coming through a kind of network layer. Physical device is laptop, but the actual physical device is a kind of a network card, like wireless Wi-Fi card, and then you get another layer which allows you to get the data. Then certain protocol of the internet which is connected with your router or internet router, and then it is communicated with some kind of gateway, and then gateways communicate with the internet, and the internet with your ISP, internet service provider, and they further communicate, and they further reach to your country, for example, and then after country they reach to your ISP, then after ISP they reach to your router, and after router they reach to your laptop, and through the network interface card, and then after network interface card it reaches to you in kind of application, and then that application is basically, so makes sense that it is traveling from certain layers. Yeah.
Yes.
Okay. So now let us go a little bit more into the detail. So there should be some protocols. You should consider there can be different protocols, and you could also assume that each protocol works at its own layer. Here I would like to ask that our OSI model.
You come again?
Have you heard about the OSI layers or OSI models?
Yes.
Yeah, Abid, how about you?
I don't have any, the deep blue, but I just heard about it.
Yes. So basically, OSI model is a kind of abstract model. Yeah.
It has operation system,
Right.
open systems interconnection model.
It's called the open system interactions.
Interconnection model. Open
Yeah.
system.
Open system interactions model, and it has kind of layers. As I explained to you, that when you talk about the OSI layers, or when you talk about the communication, if you are sending or making any a transfer of data, then it goes through the physical layer. For example, from your computer, then it is reaching to your data link layer, then network layer, transport layer, session layer, presentation layer, then application layer. So as I gave you a path, that after leaving your, for example, from the keyboard or microphone, it will go through your network Wi-Fi adapter in your laptop, then it will reach through your network like a router, and router will be connected to the ISP, and then through gateway, and it will be traveling and converted again into the same layer. So at the end, the application layer will be able to give you the actual output. So literally it travels through the certain layers. So we come here that some protocols work only at a particular OSI layer. The layer at which a protocol works describes its function. So their functions are described at a particular layer. For example, a protocol that works at the physical layer ensures that the data packet passes through the network interface card and out onto the network cable. So, as I explained earlier, that if it is the responsibility of the physical layer which will ensure that the data packet, like a data packet, if I am talking, then that voice is passing through into the data packets, and it is passing from the NIC, is a network interface card. Normally this terminology is used for the LAN cards, where you connect your laptop through the cable, and obviously you can also call your wireless adapter which is in your laptop can also be the network interface card. Yeah. So make sure you need to consider that any layer which is used, it will have its particular usage, and then protocols can also work together in a protocol stack. So the protocol stack would work like for particular kind of transmission, the group of the protocol layers would make stacks. Okay. Now, the types of the network protocols, among which the most common network protocols is the Ethernet protocol, local talk, token ring, FGDI, ATM. So, the following are some of the commonly used network symbols to draw different kind of network protocols. So, protocol, as we explained earlier, that is the kind of rule, that in which rule they will be shown kind of logically making some path. Let's say if it is Ethernet, then it would look like this. If it is a ring, then would look like a ring. Then straight bus, FDDI ring, token ring, communication link, star network, flexi node link. So these are basically the kind of protocols, and they work accordingly. Let's have a look on them in little bit more detail. If it says the Ethernet, so Ethernet is a protocol, is by far the most widely used one. The Ethernet uses an access method called the CSMA/CD, carrier sense multiple access collision detection. This is a system where each computer listens to the cable before sending anything through the network. If the network is clear, the computer will transmit. So, for example, if you are connected with if you have connected your computer on the Ethernet lane, then it won't be the case that you are sending the message or data packet over the network without confirming that if the connection on the network exists. But the Ethernet, as the description says, first it will check that there exists a path that you are going to send something. Then after confirmation of the path, you send the data into the data packet. So that is the mechanism behind Ethernet. A ring network is a network topology. Topology is a physical representation or pictorial representation that how they will be shown, in which each node connects to exactly two other nodes. So for example, if you have made your network into a ring topology, so what you are going to do, you are not going to connect your one computer or workstation, let's say, to only the modem, but you are connecting with another network device or workstation. You can also means you can communicate one computer to another computer. That would also make a network, and one computer is connected to two devices at the time, so that they can make a ring. So you can have a look here that making a ring in a network connection, it is called the ring network. So forming a single continuous pathway for single through each node, a ring. Data travels from node to node, with each node along the way handling every packet. So basically, we are going into the very abstract definitions of these type of protocols. Yeah, probably if needed, we can go into the details, but at the moment, let us see and let's have a kind of introductory, information about them. Yeah.
Yeah.
Now, a bus network, an arrangement in a local area network in which each node, workstation or other device is connected to a main cable or link called the bus. The illustration shows a bus network with 5 nodes. So you can see that it looks like a bus network and each device is connected. Now, the network hardware and software, the network devices, now we talk about another topic about the network devices. The network devices are components used to connect computers or other electronic devices together so that they can share files or resources like printers or fax machines. So, these devices are called the network devices. They help to communicate as well as share the files or resources over the network. Devices used to set up a local area network are most common type of network devices used by the public. A LAN requires a hub, switch or a router. Now let us have a little bit more details about the devices. For example, gateway. A network gateway joins two networks so the devices on one network can communicate with the devices on another network. So when you connect two networks, it means you can connect them with a gateway. Two networks probably could be like, for example, if we are in a one building and you are going to, for example, if you have a communication in between your home into your computer, so that can be considered as a one network. And possibly if you are communicating out of your home and out of your home is another person or another network, for example, you are your home network and the home network of anyone else would be connected via gateway. Yeah. So gateway is a kind of basically the connection between two networks. A gateway can be implemented completely in a software. So probably you can make it logically that you made a communication channel between two networks, or it can be made between the hardware or a combination of both. Because a network gateway by definition appears at the edge of a network. At the edge of a network means it is helping to connect the two different networks. Related capabilities like firewalls and proxy servers tend to be integrated with it. So, firewalls and proxy servers are the part of the gateway. For example, if a bank branch wants to connect with another branch, then they can be connected via a gateway. So obviously there will be some firewalls and proxy servers like a virtual private networks like a VPN will exist over there. So gateways help to communicate and join the two different networks. Now we start with the device which is called the hub. A network hub is a networking device which is used to connect multiple network hosts. Multiple network hosts means multiple computers. When you say your laptop is connected, it means it is your host. When you say it's a printer is connected with the network, then it is a host. A network hub is also used to do a data transfer. So whenever you want to transfer the data over the network, so you need at least a hub device. The data is transferred in terms of packets on a computer network. So when a host sends a data packet to a network hub, host means when you from a computer sending a data packet to a hub, the hub copies the data packet to all of its ports connected to all of its ports. All ports know about the data and the port for whom the packet is intended claims the packet. Is it clear?
Yeah.
So let me tell you that this is the older device. In olden days, yeah, people used to use the network hub, and what the network hub used to do, it used to allow you to communicate with the uh, network, I mean the network host. Like one network host wanted to host, then unfortunately the one that message, particular message, used to be sent to everyone on the port, and whoever was the recipient was the intended recipient claims that packet to be further processed. However, because of its working mechanism, a hub is not so secure and safe. Moreover, copying the data packets on all interfaces or ports make it slower and more congested, which led to the use of network switch. So, make sure and know that hub was the initial device, and it used to send data between to and from the devices which are called the host. But unfortunately all the data being transmitted was conveyed or sent to every available device on the network, and the device whom it was to be intended, the receiver, then they used to accept it, otherwise others reject it. So it was the disadvantage. Now switch. Switch is a kind of another latest device after the hub. Like a hub, a switch also works at the layer of the LAN, but you can say that switch is more intelligent than a hub. While hub just does the work of data forwarding, and a switch does a filter and forwarding. So the switches did not repeated and sent the data packets to every host on the network, but they filtered first that to whom they want to send, on which port the data is to be sent. Then the switch forwards, which is a more intelligent way of dealing with the data packet. So when a packet is received at one of the interfaces of the switch, it filters the packet and sends only to the interface of the intended receiver. For this purpose, a switch also maintains a CAM content assembly addressable memory table and has its own system configuration and memory. CAM table is also called the forwarding table or forwarding information base. So nowadays, at least the switches are used as compared to by replacing the hubs. A bridge, a device that connects multiple network segments. So computer 1, computer 2, they are the part of one network segment, and computer 3 and computer 4. And through the bridge, usage of the bridge, you connect two computer network segments. Repeater, an electronic device that receives a signal and retransmits it at a higher level or higher power or onto the other side of an obstruction so that the signal can cover longer distances. So for example, if you have a network in your home, excuse me, if you wanted your switch or your internet device connected with your laptop, and you notice that your room is very far from the actual internet device. I am using the term device because I don't want to take the name of the particular device at the moment. So if you found that your in your house your laptop is, for example, away about 300 meters from the actual internet device, then what you need to do, after allowable length of the cable, you use the repeater. It will regenerate the signals of your network data packets, whatever the content is to be traveled on the network. It will be regenerated and moved further forward. Now, modem. A modem is somewhat a more interesting network device in our daily life. So, if you have noticed around, to get an internet connection through a wire, there are different types of wires to your house. This wire is used to carry our internet data outside to the internet world. However, our computer generates binary data or digital data. You must know that computer works into the zeros and ones because it's a machine, and machine is represented in the binary language, either 0 or 1. So, on the other hand, a wire carries an analog signal, and that's where a modem comes in. So, if you consider anything which travels on the wire is in analog and your computer is digital. So how your digital data of your computer travels into the cables, which are basically the analog. I hope you should be able to understand the difference between the analog and digital. The analog communication signal travels into a sine wave, while the digital signal works into the straight line. You can have a look on the difference between the digital and analog transmission, and you will get the pictures maybe on the Google very easily, the difference between. So, a modem stands for modulator or demodulator. That means it modulates and demodulates the signal between the digital data of a computer and the analog signal of a telephone line. Yeah, but basically the telephone line is the analog device. So modulates and demodulates, decodes and encodes those kind of analog data to digital data and digital data to analog data. So the device that connects initially from your home with your internet service provider is the modem. Modem communicates to the outer world via the analog lines, analog telephone line, and it is the responsibility of your modem that modulates and demodulates to send the digital data from computer and then converting into the signals of analog so that you remain into the communication. A network router. A router is a network device which is responsible for routing traffic from one to another network. These two networks could be a private company network or to a public network. You can think of a router as a specific police who directs different network traffic to different directions. Now the question arises that what is the difference between the modem and the router? A router is a further terminology or technology in addition to the modem. In previous days, what used to be there, like you used to have a modem which was connecting with your computer signals to the through the analog lines, and then you needed a kind of switch or hub, so that instead of connecting one computer, probably you could create a kind of one small home network over the Ethernet, and then you connect your switch or hub with the modem. So your modem is connected with the outer world. It is providing you the internet, and further your internet is divided or distributed to different devices which are connected and are making a network using which device. Let's say hub or switch. Hub is not intelligent, but the switch is intelligent. However, one network router has capability to provide the functionality of a switch or hub as well as modem. Yeah. So is it clear about the router, the switch and the hub?
Yeah, it is.
Yeah.
Yeah. So these are very interesting things. Now we don't, care about that what is switch, what is hub, and what is different between the modem. But now everything has come into one thing. Nowadays, you talk about that. Do you have an internet router? When you talk with your internet service provider, they don't say that okay, we are sending you a modem. They don't say that we are sending you a switch. Am I right?
Yeah.
So they say we are sending you the internet router, but I believe that some of the internet service provider still send the modem and the switch separately. Like BT in UK, they used to give a white modem and the switch as a black separately. I don't know how about there, Lawrence. Which one do you use?
Yeah, we have two devices here installed in the house. I think one is the switch from the, and the other seems to be the modem.
Yes, definitely. The one is a modem, and that is connected to the telephone line, and then modem is connected with the switch via the Ethernet cable. Yeah. So
Sure.
that's the little intro about the modem, router, switch, and hub. Yeah.
Yeah.
Now, the network applications. A network application is any application running on one host and provides a communication to another application running on different hosts. So the application may use an existing application layer protocol such as HTTP, SMTP, and maybe the application does not use any protocol and depends on the circuit programming to communicate to another application. So that web application is a type of network application. So when you have a network, then you need an application to transmit, to communicate in between the devices. When you say a network device is based on certain host. For example, when you talk about a host, it means your device of the laptop, your desktop, your mobile device, and they need to communicate using certain application. That application can use the application layer protocol. So further, if you refer to the OSI model, then the OSI model has certain 7 layers, and any communication being made passes through those abstract layers, and then you get communicated. Otherwise, you cannot get communicated. So for your network, you need an application software. The examples of those networking applications can be email. The email is a network application software and would be, for example, would be passed through the 7 layers of the OSI, the web itself, instant messaging, remote login, P2P file sharing, file transfer between 2 accounts, multi-user network games, streaming, internet phones, real-time video conferencing, and these things are involved into or You can say that these are the examples of kind of network applications. If you have network application, then obviously you need a network operating system as well. If you don't have a particular network operating system on your devices, then obviously you cannot run your network application. A network operating system is a computer operating system that is designed primarily to support workstation, personal computer, and in some instances older terminals that are connected on a local area network. So it supports workstation, personal computer, and other devices. So for everything you need a network operating system. Examples of the network operating systems are UNOS, used in routers and switches from Juniper networks. Cisco, Timos, Versatile routing platform, Router OS, Zynos, and these are basically the network operating systems. So if you have a router, then your device needs to have an operating system. If it doesn't have an operating system, then these devices will not be able to use. So probably you must have heard that operating system is necessary to run the device, run the computer, and when it is a network operating system, then a specialized networking, the network operating system needs to be stored into that particular device, otherwise your device will not operate. Next we talk about the wireless networks. So wireless networks are computer networks that are not connected by cables of any kind. So I'm using my mobile and laptop connected to my router wirelessly. There is no cable. So when the networks or hosts or devices are connected without wireless, then you can say that it is working in a wireless network, or you have a wireless network in your home. The use of a wireless network enables enterprises to avoid the costly process of introducing cables into buildings or as a connection between different equipment locations. So the type of the wireless networks, for example, personal area network, it is a range within reach of a person. Cable replacement for peripherals, Bluetooth and Zigbee, these are the standards. Local area network is within a building or a campus. So when you say LAN, let's say you have a router in your home, it means it is a kind of wireless network within a LAN, so within a building. So wireless extensions of the wired network, whichever for example, the wired network you have is the extension or the additional provision of your network. So standard it uses IEEE 802.11. So when you must have seen your wireless routers, and they say that it supports the IEEE 802.11 protocol for the Wi-Fi. Then main metropolitan area network, within a city you want to create a wireless network within a city. So application, it uses wireless inter-network connectivity, and it works on the protocol of IEEE 802.15. So when you want the network of wireless within a city, then the protocol you need, the standard you need is 802.15. You must have not seen the 802.15. Probably the bigger devices, the very advanced devices are like specialized devices by the companies or big enterprises might be using in order to provide a wireless network at the city level. Then the wireless wide area network, when it's a worldwide wireless network access, and they can use a cellular and other protocols. These UMT, SLT, these are the cellular protocols. So the wireless networks, they have a variety of the ranges, their applications and standards. Wireless network devices, they work on a different kind of waves. When you talk about the terrestrial microwave communication uses earth-based transmitters and receivers resembling the satellite dishes. Terrestrial microwaves are in the low gigabytes range, which limits all communication to line of sight. Relay stations are spaced approximately 48 kilometers. So when you say that you are using the terrestrial microwave, so probably you have a range of 48 kilometers. Communication satellites, the usage of communication satellites via microwave radios, which are not deflected by the Earth's atmosphere. The satellites are stationed in space, typically in geosynchronous orbit of 22,000 miles. So when you say communication satellites, they have a capability to cover up to 22,000 miles above the equator. These Earth orbiting systems are capable of receiving and relying voice data and TV signals. Then cellular and PC systems use several radio communication technologies. The system divides the region covered into multiple geographic areas. Each area has a lower power transmitter or radio relay antenna device to transmit calls from one antenna to next antenna. So cellular is a kind of device. The radio and spread spectrum technologies, free space optical communication. So not only these, but there can be more advanced technologies nowadays that they are using. Next is the monitoring. The monitoring is basically the use of system that constantly monitors a computer network for slow or failing components of the network, that notifies the network administrator via email, SMS or other alarms. So when you have a network, it needs to be monitored that whether the network is stable, or if there is any missing into the network connections, then should be addressed to the network administrator. The network management system is a set of hardware and or software tools that allow an IT professional to supervise the individual components of a network within a larger network management framework. Network management system components assist with network device discovery, network device monitoring, network performance analysis, intelligent notification. So you should monitor the network, you should have an appropriate device and how the device works, at which kind of network, whether within the LAN, WAN or MAN, and which operating system on the device is being used for that particular network device, and then which application software you will be using, and apart from this, how they will get a communication over the network. If it is within the building, then it will be Ethernet network. You get connected with your router, which has a modem as well as a switch, and then you get communicated, and possibly the interconnections could have the bridge, maybe the gateway, and so on. And they basically all work under a kind of protocol and the topology, that how your network is connected, and the protocol is the main thing that every communication is getting is to be, every communication is going through certain protocol, and protocol at every level comes under the conceptual model of OSI, and following this OSI, everything, every communication undergoes. If you start from the protocol, then protocols fit into the OSI, then use the devices, and after using devices, you need the operating system of the device, then you monitor. So in the forward and reverse terminology, that is the usage and the purpose from protocol to monitoring, and the monitoring reverse, then the management and the use these devices. Yeah. So I have finished these slides. So I stop the recording, and then you can ask any questions.